Hey, John, how's it going?
Good. How are you, Craig? Happy day.
Happy day indeed. I think we're live everywhere. All I got check marks across the stream, but this is the first time we're multi-streaming. So
Yeah.
happy Wednesday to you, my friends. And we'll be back doing this again on Friday um, at our regular time, Friday at 8 a.m. And we got some interesting stuff. I took a look at some of the tech that was coming out at CES and some of the other things around and so we're going to be talking about some of those things. And actually, I put R1 in there,
Oh, good.
the thing you just sent me today, which is a
Yeah, it
great
looks like
follow up to the AI pin we talked about.
it looks to be a more usable AI pin than the humane one that we saw, I think. But we'll talk about that on Friday. Yeah, there's some cool stuff at CES. The biggest thing I saw so far is the transparent OLED or micro LED or whatever it is, the transparent TVs that they have coming out.
Yeah, some of those look good. I didn't see the videos on what they look like, but I read some articles on it. And unfortunately, I forgot to read the introduction. So I am going to do that now because this is good content we're wasting here.
Yeah.
Welcome back to Futuretech, your weekly source for latest in tech innovation and business. I'm the startup coach, and as always, I'm joined by my co-host, John Irwin. How you doing today, John?
Good. How are you, Craig?
Good. For those people listening on the podcast, you just missed some interesting discussion. Those of you watching us live, thanks for joining us. We'd love to put comments and in the section and we can respond to them. We'd love to hear any questions you have about what we're talking about. We got a very interesting bunch of stuff to talk about today, so we might as well jump right into it. Spy attire. The U.S. is investing $22 million in surveillance socks. What's going on here, John?
Really interesting. So the U.S. intelligence community apparently they're investing, I think it's like $22 million in a new program called Smart ePants. I don't know why I did air quotes there, but to develop clothing with integrated surveillance technology. So their goal is to weave audio, video, and location sensors into items like shirts, pants, socks, underwear, so that they can function like regular clothing. What they're looking to do is the technologies involved include miniaturized microphones, cameras, GPS components woven into fabric. And I would be remiss if I didn't say that they're probably going to weave some sort of biometric scanning or something like that into the clothing as well. So the reason for this is obviously so that they could covertly record information from their environment without wearing bulky, rigid equipment. And so the program's led by IARPA, which is the intelligence community's research and development arm. So it's really interesting stuff. Again, we always talk about this when we talk about new technologies, privacy and things like that. So there are some privacy concerns, but yeah, huge investment, $22 million into this.
Yeah, I was kind of scrolling through the article for the people watching us here because it's, I mean, you know, we talked about some of the things we can get from wearable energy. We can get from some of the wearable circuits they have, whether it's movement, whether it's heat, whether it's water, what do you call that? Anyway, there was multiple forms of electricity that can be generated by this wearable. Now they can build that kind of stuff right into the clothing you're wearing to power potentially. Where am I? What am I seeing? What am I doing? So will we need body cams in the future? Is that a thing of the past?
Who knows? Yeah, who knows how good the quality of the recordings will be? They should be pretty good, but I guess no longer are the days of pat downs for if you're an undercover and making sure that there's things. The biggest thing I like. So now the thing for me is the biggest challenge here is how do you detect those things for counter surveillance, right? So obviously there's some sort of radio frequency that they're going to be emitting. But how detectable is that? And is it actually going to be on, or is there going to be local storage? Like how is that going to go?
Yeah, and the idea of having to get naked for every meeting to make sure that nobody in a corporate environment is like you've got to change into your assigned clothing before you go into the corporate boardroom when we talk about our secrets is not appealing.
Maybe bathhouses are gonna come back and get popular again. That's they'll have hot tubs in the offices now, and I'll have to hop in the pool.
Yeah, so what are the challenges that need to be addressed in order to, make these garments durable, comfortable to wear? And, I'll talk about the power sources in a minute. Like right now, is it actually built into comfortable clothing, or am I literally wearing circuits board that's scratching the crap out of me?
Yeah, well, if in our previous one, we saw those stretchable printed circuits. I think that's going to play a big part in this. But embedding electronics, making them washable and maintain performance over time is going to be challenging. They're going to need to be durable, have some sort of coating or encapsulation. The other thing is distributing the weight and the bulk of the components evenly throughout the garments to avoid pressure points, so that you can wear it all day and so it's less detectable. And yeah, like you said, integrating power sources. So they have to be thin, lightweight, recharge without compromising fabric attributes. And I think I did read an article on, and we might have talked about it last episode, on expanding and contracting of fabrics can generate power. So yeah, that's going to be interesting. But also thermal management to prevent overheating, because you've got these woven into fabrics now, so there's less room for them to dissipate heat. Motion artifacts from the fabric stretching and compressing. There's ensuring the sensors and connections are moisture proof to survive incidents like rain or sweat. So there's a whole bunch of challenges that they still have to, and the cost of manufacturing. So that's going to be a whole new textile manufacturing methodology that they're going to have to come up with. So really interesting stuff, though. But a lot of challenges and a lot of hurdles for them to overcome.
Yeah, you're going to get past the pat down, because right now, for sure, you're going to need a big power supply. Is that a battery in your underwear? Are you just happy to see me?
Yeah, well, like there's paper thin flexible batteries such as lithium ion that could wrap around curved surfaces. That's one way to power it. Micro fuel cells that generate electricity through, I guess, metabolic processes like glucose oxidation, that could help to avoid. And then there's like we just talked about, the kinetic and piezoelectric energy harvesters woven into fabrics. And we talked about this again last week, is the triboelectric nano generators too. So there's a lot of different options. Apparently there's thermoelectric textiles that turn temperature differentials into power. And then you've got the hybrid energy storage, like ultracapacitors, distributed power management. So power management is going to be big, and RF signals and different things like that. So nanomaterials, I think, are going to play a big part in helping to power these and keeping them charged.
Yeah, I don't know about you, but I don't really want to be wearing any spy underwear.
I don't want any RF signals near my junk. I got enough with my cell phone in my pocket. It's going to be interesting, but I know that right now, some of the professional sports leagues, they do integrate some sort of sensors into wearables, but I don't know how comfortable they are. And obviously that's not as high tech as this. These are just sensors that are made to pick up things, whereas opposed to cameras are not made to be woven into fabrics, nor are microphones, right? So
or GPS devices.
Yeah. So it's going to be interesting to see how they approach it. And obviously, as technology grows, and we talked about this before, we've got carbon nanotubes. We've got a whole bunch of different technologies that are going to help us to minimize a lot of this stuff. And if you look at some of the spy cameras now that are on the shelves, like you've got ones that are as small as a button on your lapel or on your jacket. So it's getting there. The technology is getting there. I'm sure DARPA or IARPA has ridiculously small cameras with small camera sensors, but probably not for the mainstream.
Yeah, this is very interesting. I'm a little concerned as a person who sweats a lot of having all this electronic stuff actually in my clothes, because you figure that that's not necessarily a good thing for these things. But it's
What happens when
interesting
there's a
that,
short circuit and you're sweating?
yeah, and then you short circuit and you're lying on the floor twitching. But we've
Yeah.
come a long way from, spy technology in your clothing being, the shoe phone from Get Smart.
Oh my God, totally remember that. Yeah, the cone of silence, the shoe phone. Yeah,
And
those are
all
the
the
days. And then the watch that Dick Tracy had too. But now we've
yes,
got those. So,
absolutely. Like if we can power a watch for, all day, couple of days, we could probably power most of these things in the clothing in that kind of small, like the power source, probably you just have to plug it in every day or throw it on a magnetic charger of some sort. But
yeah.
it's very interesting to see the types of things. Never mind, the military doing it. We've always talked about. I remember I was just editing one of the podcasts where you were talking about. We're just 25 years away from being the military creating Captain America. Now we're talking about having some very cool stuff in the armor. How far do you think we are away from uh, similar to vibranium, for lack of where an impact comes in and the stuff hardens automatically because of the sensor velocity, your clothing density changes and forms around the spot to, a lot of things could happen that could really make some very interesting, cool technology.
Yeah, I don't think we're far off from anything like that, because especially with the introduction of carbon nanotubes and new technologies, new textile technologies that are being developed and being researched. I think it was, what is it, spider webs, or the silk from spiders can be used, but it's the problem is the scale of that, of how to get that to scale. So if they can scale that, then we've got a better technology than Teflon. It was funny. I was just watching a video on how Teflon really stops a bullet, and it's just multiple layers of Teflon, and it just slows the bullet down to a point where it can't penetrate one of them. So it's interesting. Yeah, there's going to be technology, and I think it all comes down to nanosensors and nanobots and all that sort of stuff. So when they sense that a bullet hits you, the bots come to life or do something to mitigate that bullet. So I think I would say we're probably 20 years off from something being in the mainstream. But
well, we were talking about just last episode, or the episode before, the self-replicating DNA robots. Easily, you throw some sensors and stuff to trigger the carbon fiber robots that repair the hole in your jacket.
exactly.
There's very cool stuff when you start putting together a handful of these things that we've been talking about.
Yeah, and it's really cool. And you can even have those replicating DNA robots fix so that you don't even bruise, you don't even show any signs. You know what I mean? Like that could be real time medical repair. You never know.
Yeah, this is very, very interesting stuff. I'm really glad we're experimenting on this stuff. I can't imagine the different types of breakthroughs that we could have with this. All what you, my mind is baffled by once you start putting this stuff in clothing and you combine it with some of the other stuff we did. Why do we need a phone anymore?
Exactly.
Our clothing does everything for us. We talk about the AI pin and the R1 we're going to look at, and all these things that we just talk out loud, and our like stuff responds to us.
Yeah, I think we're going to get to the point right now. We've got all these new XR glasses they're pretty bulky right now, but I'm actually looking at getting one, the Nreal Air 2, not sponsored by them, but really cool XR glasses that have two displays in the glasses and put them so that you can work for, like, you have a huge screen and a huge monitor, all that sort of stuff. I think we're going to get to a point where that's going to be the norm, where you're going to be wearing glasses that have your screen on it, that interface with your phone, that interface with maybe the AI pin, wirelessly and things like that, so that you're just wearing regular glasses. And even they don't have to be sunglasses. I'm talking regular see-through glasses. If we talk about the transparent technology that's being developed, that could be the way of the future. I think you're on mute.
Yes, I was. I said I started getting advertising last time we started talking about wearables and stuff for the Ray-Ban sunglasses, smart glasses. Have you seen those?
Yeah, those are more for POV kind of stuff. They've got cameras on them. They've got good reviews. The new ones do. They're good quality and they're really good. But those are just two cameras on the glasses. There's no screens or anything. But they're really cool for taking POV shots and different things like that and recording daily life. So really interesting.
So let's jump to our next topic.
I don't know why I love cellular technology so much. It just baffles me. It's phenomenal. And this is even crazier. Go ahead, Craig.
Yeah, breakthrough technology amplifies terahertz waves for 6G communication. What's this all about? And then I'm going to talk about whether it's frying my brain or not.
So actually, it shouldn't be called 6G, even though because I think I'm pretty sure the other up 5G and below are based on gigahertz at least, but I could be wrong. But this is cool. So 6G technology using terahertz waves. So researchers led by Professor Park have developed a technology to greatly amplify terahertz electromagnetic waves, which are being considered for 6G communication networks. Up until now, we've only used gigahertz technology. So this is going to be interesting. The biggest thing is terahertz wave. They occupy the frequency between microwaves and infrared light. So using nanoscale resonators combined with an inverse design method incorporating AI, they were able to amplify the terahertz waves by over 30,000 times, which is a significant improvement over previous terahertz resonators and moves the terahertz tech closer to commercialization for applications such as 6G networks. So what they did was they employed advanced AI optimization techniques based on physical models to efficiently design the resonators, taking only 40 hours compared to previous methods, which is really cool. So this could enable uses like highly sensitive molecular detection, next-gen sensors, different things like that. But the problem is, so with the 5G technology, we've already had a crap load of problems with 5G because of the short wavelength. And just a quick educational session. The shorter the wavelength, the harder it is to propagate through surfaces and bounce off surfaces and penetrate buildings and things like that. So terahertz is even more difficult. It's even shorter of a wavelength. So we're going to have a lot of problems with it. So terahertz, the good thing is it can carry a crap load of data, but the downside is that it's going to be very, very difficult to create and design networks for cellular communication.
Yeah, this is very interesting. And you talked about it. A lot of problem with 5G is that it can't penetrate the house. They have to have it close. They have to crank up the wattage, I guess, the amplification so with terahertz waves, that's going to be more of a problem? Have they talked about getting around that? Are they talking about maybe putting its smaller broadcasts inside and outside?
Yeah, I have no clue. So they're going to have to integrate active tunability. They're going to have to optimize the geometry of the nanostructure for resonances that can be tuned to specific terahertz frequencies. The other problem is traditional metal and semiconductor structures are too large to efficiently guide or enhance the terahertz waves at the sub-wavelength scale required. So there's a lot of work that needs to be done. I'm guessing we're 10, 15 years away from 6G being mainstream. But yeah, back, like, just to reiterate, like, the short wavelengths allow high data transmission rates, but the signals are weak and attenuation is high over distance. So we're going to have not only a penetration problem, but a distance problem as well, a broadcasting problem.
Yeah, I look at this and I wonder, you know, we'll solve some of those issues, whether it's exactly doing this or something else. Is this going to facilitate us being, you know, what I would call online all the time, where I'm right now, I'm always have my headphones in. I'm one of those people, 20 hours, 24 hours a day. I get upset when my headphones, I have to recharge them and plug them in for a few minutes because I got stuff going on.
Yeah.
But I'm not glued to my phone looking at it all the time, as a lot of people are. But I find now that I got my iPad up, it's got a video going while I'm working and I'm listening. Like, is this now going to make that happen all the time? Because we can be on the phone with somebody, we could be video streaming to work with whatever's going on. I could be having other things going on over here. And is that what terahertz waves are going to allow us to do? Is pretty much anything from anywhere?
Yeah, I'm guessing we could probably stream virtual reality using this technology. Like, we're talking, just to put it into perspective, we're talking 8K or 16K video distribution. That's what it could be able to handle for sure. But yeah, we're talking, like, we are kind of always connected now, but this is a whole new ball game. Like, we're talking real-time HD video streaming from vehicles, like, as far as collision avoidance, all that sort of stuff. We're talking no more need for fiber. Yeah, we're talking, like, this is a true wireless. This is a true wireless future. Ultra high resolution medical imaging, DNA sequencing, glucose level monitoring. Like, the possibilities are endless.
Now, this technology isn't really fully vetted and tested and stuff, but one of the things around 5G was response time. Like, the response times were so fast in 5G that you could do so many different things. Like, they're hoping to put it in cars and, you know, light systems, and you can detect what's moving and what's not around you. Does this make that even faster?
Yeah. So just to put it into perspective, 6G is expected to be about 100 times faster than 5G. And the speeds are expected to exceed 100 gigabits per second. So I guess even at that, you could have true hologram communication at that point. So we're getting into the Star Trek era. Yeah, it'll have much lower latency, less than 1 millisecond in real-time control applications, whereas 5G is around 1 millisecond. Sensors, yeah, there's the network architecture will have to be more decentralized and more cloud-based for scalability and reduced latency, but there's a huge difference there. But again, we're just new into 5G, right? And it's just getting adopted. And although 5G, I think, is getting adopted a lot quicker than 4G, but yeah, we're still a ways away. But there's a lot of great benefits to 6G, exponential benefits compared to 5G.
You say things like not needing fiber, but by the time this comes out, you know, we'll be able to, you know, do terabytes down a fiber or petabytes or whatever. So we have to keep in mind that usually physically connected scales just as fast as the wireless from a bandwidth point of view.
Oh yeah, we'll need fiber for the backbone for sure.
And you know, there's always a rule, like, no matter how much bandwidth, you'll fill it up somehow, right?
Yeah.
There was that screensaver back, I think, I can't remember, was it in the 90s, that get stock quotes and stuff that was killing all the corporate networks because people were loading up this screensaver and it was pulling all this news and stuff data, and it was clunking down all the internet. Yeah, so we find a way to fill it up.
Well, now people will probably just install these holographic communication devices into their homes, and that'll eat up all the bandwidth.
So I go to, is there going to be, you can't answer this question, so it's unfair for me to say this, but there was a lot of stuff around millimeter waves affecting humans and DNA and brain matter. How much of that is true, how much of that is not true. I think we have too much electromagnetic waves spewing around us in our house all the time that we are affected in some way, shape, or form. Is it like as cancer causing or stuff that some of the naysayers do it, or positive, or what? I don't really know, but I got to think that it can't, uh, the ever increasing amount of waves that are going through our body can't be good for us.
No, it definitely can't. And there actually are some studies that have done, and there's this device that you can get that helps to reduce the amount of waves that are getting into your body. It's a little sticker you put on the back of your phone. I don't know if it's snake oil. I haven't looked into it. I just actually saw it a couple of days ago. But the thing with millimeter waves, though, are they're a type of non-ionizing radiation on the electromagnetic spectrum. So they don't directly damage DNA like what ionizing radiation would do. There were, I think, and this is just me just trying to think about back on my research, but there were some animal studies that did find biological effects at very high exposure levels. However, the exposure levels were many times higher than what humans would experience from 5G or Wi-Fi use. So again, it's a lot of propaganda, I think, but who knows? It's a newer technology. Although millimeter wave technology and gigahertz technology and terahertz have been known for many, many years, I don't think there's research, but there are some studies that people have reported non-specific health complaints like headaches or sleep issues due to millimeter wave exposure, but it's hard to say whether or not that was to millimeter wave exposure or to other things. So, but there's been, based on the actual research, if we go to the research that's been done, there's been no consistent research that shows that there are detrimental effects to millimeter waves or any kind of non-ionizing radiation.
Fair enough. But they say that Havana syndrome was caused by crickets. So, go look that up. Anybody who hasn't followed that fiasco. You remember that?
Right. Yeah.
Where people in the U.S. embassies were fallen ill from some sort of sonic attack.
Yeah. I still believe that there was some sort of, they do have devices like that microwave. Those are microwaves that are devices, but they actually have those for anti-riot protests and things like that. They have mounted on trucks and things like that, but really interesting.
Of course it was something like that, but they had them at a bunch of US embassies. It was happening all over the world at one point, and then it came out, they said, "Oh, it's crickets. Crickets caused this." I'm like, "Oh, okay." So you found out somebody was doing something to you, but you can't tell the world about this technology yet.
Exactly. Yeah. The one thing, just to talk about waves or radio frequencies, the one thing I'm worried about is this wireless power, which we don't have to get into today, but yeah, wireless power, because there is technology nowadays, for those of you that don't know, that you can have a device just sitting in a room and be charging wirelessly just from power being broadcast within that room. So that's the one thing I'm worried about.
Yeah, you're not talking about the Q pads or whatever where you stick it on the magnetically connect. You're talking about there's actual power being broadcast through the air like Wi-Fi, and your devices are getting charged, which is one of the next generations of things. And we talked about beaming power from space at one point.
Yeah.
And so these things are slowly becoming a reality. And yeah, we have to understand how it affects our electrical system, our magnetic system, the waves that go on in our body. But the benefits we're going to see are going to be interesting. And I got to wonder, there's a lot of benefits, but are the benefits going to outweigh the consequences? We talk about the social impact of, social media and screen time and being hyper connected globally and being hyper disconnected locally. And now we're going to add 6G on in like 5 to 10 years. We'll talk about that in a minute. And allow all this more hyper connect. Like, is this the end of local relationships?
Yeah, exactly. Yeah, especially if we're getting into holographic kind of the communication, for sure. Who knows? We've already gotten past the local connections, and with all these dating apps and things like that, you can meet anyone from anywhere in the world. Even back in the day, MSN Messenger, you could talk to anyone anywhere in the world. And Skype back in the day, you can video chat with anyone. So this is just going to get that much more realistic, I think, once we get to 6G, for sure.
So the rollout of 4G was faster, and the 5G is faster than 4G. Is 6G going to come faster, or is it going to take a while? Like, they're still finishing rolling out the 5G. This technology is fairly new. How far are we away from it, and what are the challenges with rolling it out?
Yeah, I think we're 5 to 10 years off commercialization of 6G. And there's so many challenges that are faced. So again, we talked about shorter wavelengths. So they're 100 times smaller and pose unique challenges for generation, propagation, and detection. We've got the higher frequencies, so scaling devices and techniques to frequencies over 100 times higher than 4 and 5G. That introduces obstacles like we talked about: increased attenuation, need for sophisticated nano fabrication. So we're talking like nanoscale fabrication now, manufacturing. Again, it's an immature technology. So terahertz science is still relatively new, and it requires extensive research to discover enabling materials, devices. Again, we've got the sensor detection limitations. So developing compact, efficient, tunable terahertz sources and hypersensitive detectors, propagation constraints, terahertz wavelengths. They kind of interact strongly with matter. So they require pretty much line of sight, and they're unable to penetrate structures like the lower bands, which diffract around obstacles. So yeah, there's a lot of challenges, but there were challenges when we got to the gigahertz as well. But I think terahertz is even more challenging because it's a lesser known technology, a lesser research technology at this point than gigahertz was.
So there was a whole real estate, I guess, surge when we wanted to put up towers everywhere. You'd pay to put up your 3G tower on a apartment building so you get the best signal. And are we going to see something like that for this kind of technology, because it can't penetrate buildings? So we're going to see like one provider only service in a mall or buildings or apartments?
I don't think so. I think because of the demand and the need for it, I think there's going to be either someone that just builds the infrastructure, and it's going to be, I think what's going to happen is it's going to just be built into the buildings when they get built nowadays. And so I don't know if there's going to be one person that owns the infrastructure, or if it's just going to be leased out. I don't. It's going to be interesting because there's going to be a lot more need for a lot more antennas and distributors than with 5G or even with 4G. Yeah, with 4G and 3G, you could just put up a tower and it would propagate miles. With 5G, you needed a lot more closer antennas and technology and things to get the proper coverage you needed.
Yeah, and having this stuff built into buildings is interesting. But with the technology rapidly changing, it's going to have to be modular. There's some stuff that's going to have to be done. I'm just curious if we're going to start seeing stuff like these chips put into other things, like your home cable box modem, or other things that'll just you'll buy, so you'll have the availability of this technology in your home without having to worry about penetrating.
That's what they're going to have to do, probably. Yeah. And yeah, there's a lot more challenges. So, and talking about the challenges, I just did a quick researching. So 4G took around 5 to 7 years from start to significant availability. 5G actually took 7 to 10. It's still being deployed, so they're anticipating 7 to 10. So with the 5 to 10 year frame, I actually think that might be off based on the terahertz technology. So we'll have to see.
Yeah, people probably don't know this, but I was working at Bell Mobility when we were rolling out going from 3G to 4G, the LTE network across Canada. They were on quite the deadline, and our team deployed the HSPA network. I think that's what it's called. It's been a long time. But we had to get it done before the Olympics in Vancouver, because there's so much money involved in roaming. You have no idea when something like the Olympics happen and thousands of people from out of country come. It's so much money for the telecom companies.
Yeah, the roaming fees, and now there's less and less because you've got the roam like home, you've got all these different things, but who knows? But the biggest thing I think when we're talking about cellular is we need more competition here in Canada. We can get controversial here, but Rogers promised that they wouldn't raise rates, and now they are. And so what's Bell going to do? What's Telus going to do? Like, there's just,
Yeah, and I had several conversations with Bryce Seschuk, who was a CFO of Wind Mobile way back in the day. And you see Anthony LeCavier, he's constant. He wants to buy it back, Freedom Mobile, and take it private again. And he's on a campaign to do that. There was a lot of trickery going on. Like, I was working with Bell Mobility when a lot of stuff was happening. They had the strike, or the people who climb the poles. Like, my brain is not working this morning. I need another cup of coffee before we started. They all were on strike, and there was a bunch of stuff going on, and there was underhanded on both sides. And it's interesting. I'm not going to, if you want to know some inside junk about these companies, come talk to me and buy me a beer sometime, and we'll chat. But the mindset of the companies is really don't kill the cash cow, right? So as mobile starts to become the cash cow away from landlines, and you say starts to, but they were charging $100 a landline, and it was all profit. It's just crazy, which is one of the reasons they refused. We at one point had a solution when Rogers was eating their lunch on the $20 a month phone at home plan. And we had I was working with CGI and working inside Bell Mobility, and we had a plan with Bell. We had a meeting with them to propose this new standard that will allow them to do VoIP at home and all that kind of stuff. And we had the stuff ready. And at the end of the meeting, so that's all great, but we're not going to do it because we literally make too much money off the landline. We're not going to offer another solution.
Yeah,
we don't care if our business is being eaten.
Yeah, no, it's crazy. It's crazy to think. Yeah, and it's just it's nuts. We've got some of the highest rates for internet and mobility in Canada, in the world, and that's due to, I think, lack of competition. So we'll have to see what happens.
Competition, lack of infrastructure. In a socialist country like we are, you would think that there'd be a little bit more of a infrastructure for these things, but guess not.
No.
All right, I want to jump to this next one as I get the website up. Hydrogen-powered aircraft completes first flight and is voted breakthrough technology of the year. What's going on here?
I love hydrogen technology. I think it's the future, and I don't think EV is the future. I think hydrogen is. So this is a great article for me. So what happened was a hydrogen-powered aircraft developed by Zero Avia completed a successful 10-minute test flight which represents the longest flight powered by a hydrogen fuel cell to date. The aircraft used a 6 kilowatt proton exchange membrane fuel cell to generate electricity from hydrogen stored as a compressed gas. And there's different ways that you can generate hydrogen. So this is one way they went about it. The cool thing about this was the achievement was voted the breakthrough technology of 2023 in a survey conducted by MIT Technology Review, which really is interesting given all the other tech that we talked about that was developed in 2023. So this just highlights the promise of hydrogen for greening the aviation sector, and not just the aviation sector, the trains, planes, automobiles, ships, all that. It's just a little bit of background. So the aircraft took off from an airport in the UK with half powered by hydrogen fuel cell and battery combo. So it wasn't just pure hydrogen fuel cell. They also had batteries on board to help power it. So no gas or no aviation fuel that was used. And so a little bit was used by jet fuel for comparison, but that was it. So Zero Avia are aiming to commercialize this technology by 2025, which is really soon. We're talking a year from now. They have over 1,500 pre-orders, and they've raised about 140 million from investors, including Bill Gates, which might not want to talk about him today, but yeah.
Yeah, and I read the other article, which I'm going to pop up here as well. This stuff is really cool. I know you're a big fan of hydrogen, so this was great when I came across this one. But it turns out, this is like the 10th test flight. The 10th flight of the initial series was completed in, July. So talk about future rangers of the system and teeing up a cross-country flights as the next stage. And they've seen the campaign has tested the aircraft up to 23 minutes in the air.
Oh,
so
a lot longer than 10 minutes.
Yeah, the campaign has seen it fly 5,000 feet, perform 23 minutes, operate in a wide temperature. This was a secondary article. I just thought because it had a little bit more info, not as much as specifically on the flights, and temperature range from just above freezing. So it's interesting. It's interesting to see. Are we going to see? You say 2025? Like we saw these issues with Boeing. We had another crash recently, not a crash, sorry, an issue where
a window explosion.
it was a door that was covered over. So if you want to know what happened there quickly, they get the delivery of the plane from Boeing, and they change the seat configuration. Now I've heard two things: they change it to make more seats, or they change it to get leg room. Either way, they change it, and when they change it, they don't need as many emergency exits because of the number of people on the plane. So they seal this one off. There's an emergency exit door that gets improperly sealed off there, and that's what causing the problem. And so this is like an aftermarket kind of thing when it arrives at, and they've done some recent, since this, they found that there's a bunch of loose screws and nuts and bolts securing this. So these have been grounded till they fix it. But this is the 757 Max. Are we ready? We have Boeing and Bombardier building, long standing companies that we're supposed to trust. Though I've got a story about that. And we've got these new companies, Zero Avia, coming out with brand new planes. Are we just gonna trust them? Like, I love this technology, but somebody who can manufacture thousands of planes and have them all fly.
I think so here's the thing. I think that they have more to prove than Boeing and Lockheed and all these other, because Boeing has this reputation, whereas Zero Avia doesn't, of safety. Well, not so much anymore, but they did. which is why, and we can get into this or not, but that's just why the FAA entrusted them to kind of do their own audits. So,
Yeah, which has caused all these problems.
Which has caused all these problems, and it apparently hasn't been fixed. So I think if I would put my trust more into a company like this, which needs to prove itself, which needs to be safe from the start and all that sort of stuff, rather than Boeing. Sorry, Boeing.
Yeah, so I used to be friends with a gentleman who was an engineer at a Canadian plane manufacturer, let's just say, and not to name names or anything. And one day, he comes in and we're chatting. We're at the local pub, and he's really upset. And I talked to him, and he said, it turns to me and like in the deadest voice, this is Craig. All I can tell you honestly is don't fly. Don't ever fly again. It's not safe. And I go, all right, dude. I trust you. This is what you do. I don't know what the issues were around some of these things that happened, but you can see as this stuff comes out with the FAA outsourced their review process and the auditing to the builders of the thing, that stuff was happening and corners were being cut. I agree that they probably have more to lose. Well, I don't know. They don't have more to lose because Boeing and Bombardier are worth what, billions and billions of dollars. That we're not there yet. But yeah, I'm concerned about that. But I agree that there'll probably be more quality control and thoroughness on these things as they're brand new than say the existing companies.
Yeah, for sure. Yeah, they've got more to prove. Yeah, whereas we've got the legacy here where they really don't give a shit about. They care about profits.
Yeah, so let's get into the tech a little bit. Do you know anything about the weight to power ratio of hydrogen versus the other fuels we've used in the past?
No, I just know, obviously, we both know that hydrogen is less energy dense. So liquid hydrogen has a lower energy density by volume than jet fuel. So that requires larger, heavier tanks, but density is improving. The other thing is efficiency. So fuel cells convert hydrogen's energy directly to electricity with up to about 60% efficiency, which is higher than combustion-based alternatives, interesting enough.
Yeah, I'm just concerned about how much are we reducing the number of people we can do in an airplane, because these are going to be some combination of hydrogen and battery powered, which is going to increase the weight of our aircraft significantly?
I don't think so, because in the article, their future goals were to include larger 19-seat and 40-seat aircrafts powered by hydrogen fuel cells, so solely hydrogen. So I think the technology is at a point now, it's at the precipice, it's at the cusp where it is pretty much usable in transportation. But it needs a little bit more to get there to be commercially viable in airplanes. But I think the technologies, or at least the hydrogen technology, is there.
Yeah, they're talking about that one test flight. Was the one was with a 19-seat plane for sure.
Yeah.
I don't know what the other ones were. If it's the same, it's a ZA 600 plane. I don't know enough about that. So I'm a little concerned about the weight ratio.
Yeah.
What are the challenges in developing, hydrogen refueling network? So, hydrogen's unavailable now. We have big refueling stations at these airports. We're going to have to do something like completely rebuild this. How does this work?
Yeah. So the biggest thing, production costs. So electrolysis or steam methane reforming is needed to produce green hydrogen adds. It's going to be pricey compared to extracting hydrogen from fossil fuels. Transportation, hydrogen is difficult to transport via pipelines like natural gas due to its small molecular size. So tankers are an alternative, but then you increase your distribution costs, storage. So although hydrogen has a low energy density by volume, it requires large pressurized tanks, which are costly. They're heavy, they take up more space than fuel tanks. Also, complexity. Hydrogen refueling stations involve compressing, storing, and dispensing the fuel safely, unlike standard gasoline diesel pumps. So, complete opposite. So, it increases installation complexity. Again, new safety regulations are going to be needed, new codes, new standards are going to need to evolve globally to properly address the flammable range of hydrogen and the different hazards than conventional fuels. Right now, there's low demand, so that's another challenge, and then public acceptance. So those are two challenges for any technology, but I would say those are the main challenges.
Yeah, I think there's obviously the challenge around am I filling up a tank or am I just replacing a tank? And the fact that the seal has to be so, like, I used to drive a propane powered vehicle for a while, and you go to fill it up and you get that psh when
Yeah.
it's the seal's not quite right and the propane's leaking out. That happens in hydrogen, you're dead.
Yeah.
Hydrogen hits the oxygen and boom. So like that has to be locked down from a consumer point of view, because we talked about trying to get that into your car, trying to get that now where is somebody running up with a fuel truck and you can't just dump liquid in, you've got to have a interesting connection. I'm curious to see how this goes from a scientific to a consumer level fueling process.
Yeah. What the thing is like jet fuel is flammable, gasoline's flammable, so it's just a matter of coming up with.
But they're flammable. But if you spill a little on the ground, with hydrogen gets mixed with oxygen, that's what causes the combustion. You can't spill it because it explodes.
Yeah. Sure.
So it's like that's what I mean. They can't stick a nozzle and have it. It's got to be airtight, sealed tight, locked in. So that's the technology that we haven't consumerized.
The other thing is don't store hydrogen, store water, and then
you can't do that.
What do you mean?
How do you do that? Because it costs so much energy to convert the water to hydrogen, more than the hydrogen gives off. So
right now.
Yeah, absolutely right now. Yeah. And it takes so long that you're going to be constantly doing this. So like airports could have solar farms potentially, but that becomes an issue because, you know, I imagine that's a issue for planes flying, all the reflective crap. Unless you can get non-reflective. I'm sure you can get non-reflective. So they're, I would see them building solar and wind farms around them to produce the hydrogen. But we're talking about a lot, and you're right. Right now, it takes more energy to produce it than it does give off. So it's a question of at what point in the future does that flip?
Yeah, for sure. Yeah, yeah. Again, we're at the cusp, but there's still a lot more development that needs to be done. But we need to start thinking about the infrastructure now and start thinking thinking about all these things now. For us to get to a viable usability for it.
I agree. I like what's going on here. I like the concept of hydrogen, and when we can get it where it produces more energy than it does to produce the hydrogen, then we've got a definite winning formula to move forward. I'm really excited about this. We're going to see these out there in 2025. They got an order for 1,500 last time we checked. So I'm really interested to see where this goes and, how they are priced compared to similar regular powered engine planes.
Absolutely. Yeah, it's going to be interesting. And to see other use cases and adaptations for hydrogen into transportation and other use cases. So it's going to be interesting.
Indeed. This has been great. We're back on a regular schedule on Friday morning at 8. So we'll see you in a couple of days. But what do you got? Anything to promote?
No, just there's a program happening right now called CDAP, for those that don't know, Canadian Digital Adoption Program. If anyone is looking for a zero interest loan to buy hardware, software, anything like that, feel free, reach out to me. I'm happy to have a conversation and help you expand your business, help you get more sales and things like that. That's primarily what I'm focusing on.
Fantastic. And we've got lots of stuff going on. We've got Startup Pitch Battle online happening again. We've got Startup Face Off kicking off. We've got Startup Investor Drinks happening every month. The next one's January 25th. I'm not sure if this will be out before then. We have co-founder matchup event in February, which will be exciting at Futurepreneur. We have a bunch of new stuff going on. If you want to work with me, check out startupcoach.ca. But all that stuff will be on torontostarts.com. Go there, check out everything. And thanks for listening.
Thanks so much. And thanks for the conversation, Craig. Always a good time.
Indeed. Thanks, John.
Take care.